Welcome to Vinita's Math channel. This is the solution videos for the problems what they have mentioned in what the problems are given in digital design with an introduction to Verilog HTL 5th edition. Okay, the authors are Morris Mano and Michael. In this playlist you will find the solutions for the problems given in this textbook. Okay, this problems these are the part of the VTU syllabus, VTU 2022 scheme. In this scheme the BCS302, okay, BCS 302, this subject has these topics. So I have made a different playlist for the solutions of this problem. Okay, the solutions, the exercise sums will be provided in the different playlist, whereas the theory part, the explanation of this subject, will be provided in another playlist, whereas the problems will be provided in the another playlist. You can check in the playlist section. Okay, the questions first. This is the printout what I have taken for the to solve the problems. You can check the page number, it is 69. This is the printout of this book. Okay, Morris Mano and Michael. The first problem is 2.1. Demonstrate a validity of the following identities by means of truth table. What you have to do, you have to prove this. Check the validity means you have to prove this by means of truth table. We have to use the truth table and prove the following identities. De Morgan's theorem. De Morgan's theorem for 3 variables. He has given all the 2 statements, that is for 3 variables x plus y plus z. This what bar is there, the meaning of this is, it is dash, the meaning of this is bar. That is, even you can write a bar or a complement in this, x bar or x dash. These are the different representations to write a complement. X plus y plus z whole bar is equal to x bar y bar into z bar, and x y z whole dash. Okay, that must be equal to x dash plus y dash plus z dash. These are the 2 identities we need to solve now. So to start with, I have taken a problem here. Next, how many variables are there? 3 variables. Okay, x y z. So I have taken x y z 3 variables. Next, since 3 variables, 8 entries, 2 power 3, right? 3 variables, so 2 power 3 entries. 2 power 3 is equal to 8 entries. The values from 0 to 7. Okay, x y z. Next, what are the ingredients you need here? You need x bar, y bar, z bar. So we need to find the x bar, y bar, z bar. Quickly we will solve this. And then next, x plus y plus z. I have taken this expression and writing what are the ingredients I need to solve this. Always remember this within bracket now. Next, the contents within the bracket, this must be evaluated first, right? So x plus y plus z. X is there, y is there, z is there. Okay, x plus y plus z. After this, the preference will be for NOT gate. NOT gate, so I have taken a bar in the next column. Next, we will look for any AND operation is there. AND is there row. So x bar into y bar into z bar. Here we are already having x bar, y bar and z bar. So we will AND all these 3 contents and we will write here. Next, x, y, z, x into y into z. Okay, we are having x, y, z here. So what we have to do? AND operation. Okay, after the AND preference, see the contents here, these are within the bracket, so I have to evaluate this first. This is not, this bar or this dash is not only for the x, this is for x, y, z. So this is within the parenthesis, so the contents within the parenthesis must be evaluated first. So x, y, z must be evaluated first. Next preference is for the NOT gate, so take a bar of it. Okay, here I have written x, y, z whole bar. Next, x bar plus y bar plus z bar. Here we will be having x bar, y bar and z bar. What I have to do? I have to do the OR operation. Okay, you got to know the skeleton of this truth table for this problem. Now let us start. X, y, z is there. What I need? X bar. What I need? X bar. So complement of x, 0 is there, 1 1 1 1, it is 0 0 0 0. Okay, next for y, y bar, take the complement. For 0 it is 1 1 0 0 1 1 0 0. Always put a finger. Next, z is there, z bar. So 0, for 0 the complement is 1 0 1 0 1 0 1 0. Next, x plus y plus z. For doing the operation, for doing the OR operation, if any one is there, we have to write the 1 in the output. Okay, so x, y, z, x, y, z. Okay, I will look for at least one. If I find, I'll write 1. Okay, no 1 is there, 0, 1 is here, 1 1 1, so 1, at least 1 1 1 1 1 1. Okay, I have already explained how I wrote this in the last video. You can start from the video 1 so that it will be easy for you to understand the concepts. Next, x plus y plus z whole bar. So we have already found this. What we have to do? We have to take the complement. So 0 complement is 1 0 0 0 0 0 0 0. Next, x bar into y bar into z bar, x bar, y bar, z bar. Okay, into is there, so we have to look for, if all the ones are there, then only I'll write 1. If not, it will be 0. Okay, all ones are there. What I have to write? 1. Look for all ones. Okay, don't write anything. 1 1 0 is there, no. 0, all ones are not there, no 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 no. So what you have to write? You can write directly the zeros. Okay, always write if all the ones are ones. Okay, sorry, if all the entries are ones, then write 1. Okay, don't enter anything in between. After that, for AND gate, in the last you can fill all entries with zeros. Okay, next, x into y into z. For this x, y, z, look for all the entries as ones. Okay, no entries, no no, don't write anything, no 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 no, yes, right? So what you have to write here? You have to write 1 here, all the entries with zeros. Okay, next, x, y, z whole bar. So the complement of this, for 0 it is 1 1 1 1 1 1 1 and it is 0. Next, it is x bar plus y bar plus z bar. Where is our x bar? This is x bar, y bar, z bar. This is OR operation. If at least one entry is 1, then we have to write 1. So at least one entry is 1, so 1 1 is there, at least 1 is there. Okay, 1 1 1 1, no entries, right? Okay, you understood this? Now let us compare x plus y plus z whole bar. Okay, this column, this must be equal to x bar into y bar into z bar. This column, both these two columns are same, these two are equal. Okay, these two are equal, so this is proved. And x y z whole bar, x y z whole bar, this column and x bar plus y bar plus z bar, this column. These two contents are same. Okay, so thus it is proved. Fine. Next problem 2.1 B, the distributive law x plus yz is equal to x plus y into x plus z, and the C problem is distributive law x into y plus z is equal to xy plus yz. Okay, both are distributive law. So what I am doing is to reduce the time of explanation and to reduce the time of writing, I have clubbed 2 and 3 and I am explaining you in a same truth table. Okay, while solving, if they'll ask only one, okay, if they ask two also, you can do the same thing while answering. Okay, in the problem distributive law x, y, z, here they have already told it is for 3 variables, right? X, y, z, the variables x, y, z, I have taken 3 variables, so 2 power 3 entries from 0 to 7. Okay, I have already taken. Next, what are the ingredients I need? X plus yz. Yz I need, so I have taken yz. Okay, next column is yz. Next, x plus yz. X is here, yz will be here. I can do the OR operation. Okay, this will be done. And the next, x plus y I need. So x plus x is already here, y is here, so do the OR operation. Next, x plus z. X is here, z is here, do the OR operation. Next, x into y plus z. The contents in the Boolean function within the bracket must be evaluated first. So y plus z, y is here, z is here, I can find y plus z. After this, I have to do the AND operation with y plus z with x. Okay, here is x, so x into y plus z. Okay, next xy. X is here, y is here, do the AND operation xy. And next xz, AND operation. Next, do the OR operation of it. Why we are first ANDing it first? NaO. Okay, the expression what we have to perform here is xy plus xz, right? While solving this part, go for the order of precedence. Okay, while solving any Boolean function, you have to look for this always. In this, is there any bracket? No bracket. After the bracket, next preference will be for the NOT. Is there any NOT gate? No. Next preference will be for the AND gate. Is there any AND gate? Yes. X into y is there, so I have to perform this first, xy. Okay, is there any AND gate in this expression? Yes. Xz. Okay, we will perform this. Next preference will be for the OR gate, so I am doing this OR gate. First I am calculating the AND gates. Okay, next we will performing the OR gates. Fine. Now let us fill this table. Okay, x into z, check for all the ones. AND gate. Okay, no, all the ones, so 1, no, all ones, so 1. Okay, rest it must be filled with zeros. Fine. Next, x plus y bar z, yz. This is x, this is yz. Okay, OR operation, look for at least 1 1. Okay, no ones, 1 is there, so 1, at least 1 is there. Okay, here. And one more thing what you can do is, in this x, here all the entries are ones. You can directly write 1 for this x plus yz. Okay, since all these entries are 1 here, you can write directly. At least 1 must be there, no? So in this column, all these are 1, so write 1 directly here. Okay, next for this only you can check. So for these entries, what you have to write? Zeros. Next, x plus y. If at least one input is 1, it will be, output will be 1. No, 1. Okay, rest zeros. X plus z, 1, 1, 1, 1, 1, 1. Rest must be filled with zeros. X plus y, that is this one, into x plus z, this one. So look for all the ones. No, no, no. Ones, 1, 1, 1, 1. Okay. Rest must be filled with zeros. Y plus z. Y plus z. Look for at least 1, 1. Okay. 1, 1, 1. No. 1, 1, 1. So fill it with zeros. X into y plus z. X into y plus z. Correct? X into y plus z. Into is there. Look for all ones. No, 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 no. Here it is. So 1. Yes. Yes. Okay. Others, enter it with zeros. Next, x into y. X into y. Look for all the ones. No, 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 no. Here it is. So here it is 1. And it will be 1. Rest, enter it with zeros. Okay. X into z. X into z. Look for all ones. Okay. 1 is there. No. Yes. So the other columns, the other entries must be 0. Next here, x y plus xz. X into y, x into z is ready. We have to do the OR operation. If any 1 is there, we can write 1. No, 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 no. 1, 1, 1. What I have to write here? Zeros. Okay, this was the problem. We have to prove this using the truth table, right? See now, x plus yz, this column, okay, this one, and x plus y into x plus z, x plus y into x plus z, these two columns. Okay, these two columns are same. Correct? So this is proved. And then x plus yz, sorry, x into y plus z, this one, this column, and xy plus yz, okay, this column. Both are same. Okay, understood? If you follow the methods what I have just told you, it will save your time. Okay, next problem is 2.1 D and E, associative law. X plus y plus z, okay, within the bracket y plus z is there. So according to the rule, what we have to do, first we have to solve this. Okay, this is the problem, is equal to x plus y, first this, plus z. X into y plus z is equal to xy into z. Okay, so to solve this, the contents within the bracket, follow the now rule. Okay, the contents within the brackets must be evaluated first. X, y, z I have written. Next, y plus z within the bracket, y plus z. Then OR operation with the next. Okay, in this expression, always look for the parenthesis. Is there any parenthesis? Yes, the contents in the parenthesis must be evaluated first. So y plus z, fine. Is there any NOT gate? No. Is there any AND gate? No. Is there any OR gate? Yes. So go for OR operation, that is x plus y plus z. Fine. Next, here the same rule. For while solving this expression, is there any bracket parenthesis? Yes. So the contents in the parenthesis must be evaluated first. So I have taken x plus y. Next, is there any NOT gate? No. AND gate? No. OR gate? Yes. So write x plus y plus z. Similarly for this, x into yz. Okay, the contents in the bracket, that is yz, have to evaluate it first. Is there any NOT gate? No. Is there any AND gate? Yes. X into yz. So x into yz. Is there any OR gate here? No. So we will leave. Next, this expression. For this expression, do the same thing. Is there any bracket? Yes. XY. So write XY. Is there any NOT gate? No. AND gate? Yes. Do the AND gate. XY into Z. No OR gate. Okay. So now let us fill this table. Y plus Z OR gate. So look for at least 1, 1 and write 1. Okay. 1, 1, 1. Here you can enter zeros. Next, x plus y plus z, that is y plus z, it is already ready and it is odd with x. Okay, so zeros, look for only one ones, at least one ones. Okay, ready, so this will be 0. Next, x plus y, only these two columns. Okay, knows at least one. Okay, 1 1 1 1 1, fill it with zeros. It saves your time. If you follow this method, it saves your time. X plus y plus z, x plus y plus z, these two columns. Okay, 0 1 1 1 1 1 1 and 1, this will be 0. Fine. Next, y into z, this two. If all the inputs are 1, then only you have to write 1. So 1 here, 1. Fill other entries with zeros. Next, x into yz. Yz is here, x is here. Okay, 0 0 0. See, for in this column all the entries are 0. Okay, don't look at this. When you have at least 1 0, you can enter it as 0. Okay, 0 0, here 0, it is 1. Here I have to write 1, all the entries as zeros. X into y, only these two. So here I have to write 1, other entries as zeros. Xy into z, xy is here, z is here. Okay, check for all the ones. Okay, no, yes. Okay, 1. So all the entries with zeros. Now we have to verify. X plus y plus z, x plus y plus z, this column. Okay, this column, this is to be equal with x plus y plus z. These two columns are same. See, all the entries are same, right? Similarly, x into yz, which must be equal to xy into z. These two columns, see, both are same, the entries. Correct, no? Okay, this completes the 2.1 problem. If you like this video, do hit the like button, share it with your friends, and comment your opinion. And if you have any suggestions or if you have any doubts, you can comment, and even you can share your views about this channel and about this initiative in our Telegram group also. You will be getting the notes of this in the group. The link of the drive, the notes link of the drive will be provided in the description box as well as in the Telegram group. Okay, thank you for watching. Happy learning.